Alright, today we are going to talk about increasing and decreasing function using calculus and decreasing function. Alright, so we need to know how do we find the gradients of increasing and decreasing functions. Okay, let's start. We have a graph here. I'm going to start drawing the graph for you first up so that you have a better visualization of what is happening. So the graph looks like this. Okay, so this graph is a cubic curve. Okay, and it looks like that. So find the range of values of x for which the y is increasing. Okay, all look here. Where is y increasing from the graph? How many places, how many parts of the graph will y be increasing? How many parts? The answer is 2 parts. During exam, you don't have the graph. So you just need to trust your steps are correct and trust that you'll get the answer. So these are the 2 parts that you'll get the increasing function. The red part. So what happened to the gradients when that part is increasing? What is happening to the gradients? Look at this red part. The gradient is always positive. So what do you know about gradients in this topic? When you have gradients, what comes to your mind? dy dx. So let's rephrase the question. Find the range of values of x for which dy dx is greater than 0. What about decreasing? What happens if the question asks you what about decreasing? Yeah, dy dx is less than 0, which is the black color part. Okay, so I'm going to answer in red. So because I use the red color part, so let me answer in red. So very simple, just do dy dx. dy over dx is a polynomial. Bring down the power minus 1. Bring down the power minus 1. Bring down the power minus 1. So I need this to be greater than 0 because I want to find the parts that are increasing. Now, don't factorize first. Divide everything by 6. Divide everything by 6. Divide everything by 6. And you have to do this. I chose this question to revise on you, to revise with you the quadratic inequality. Until now, I'm still very scared of this topic because of your. Okay, so why am I so worried about this topic? Because you always make this mistake. What is the answer? Okay, go and work out what's the answer. So it is a U-shaped curve. Most of the time, I will make it U-shaped because positive x squared. All right. Okay, so I know it's a U-shaped curve. What are these two numbers? Negative 2 and 1, right? There's 2 types only, 2 types. The first type is down here. And the second type is at the bottom. Which one is it? The top part or the bottom part? The top part, the answer will be x less than negative 2, x greater than 1. The bottom part will be x is between 1 and negative 2. There's only 2 types only. Why is it like after 1 whole year still struggling? Okay, which answer is it? The red one or the blue one? Answer is? Which answer? Red or blue? Red lah, okay? Answer is red one. It's more than 0. It's above. Okay, the answer is this. Okay, so this is the answer. Correct? I just mentioned this. What do you think this number is? Class, look here, please. What do you think this number is? This number is actually negative 2. And then this number is 1. So it is increasing when it's less than negative 2, which is why I drew the diagram for you first. And it is increasing when x is more than 1. Now, what happens if I take the middle one? You realize that it is decreasing. So between negative 2 to 1, it is decreasing. So the method works. All right? Now, when dy dx equals to 0, just as a quick revision, I'll keep this here in the video. It is a turning point. You will need this. Hey, please, this one important. So this part here also dy dx equals to 0. This part means what? It is the turning point. So let's write this down, turning point. This is very, very important concepts, turning points. So as turning point, dy dx is 0. Hey, please note this, please, very important. Increasing function, increasing part, dy dx greater than 0. Decreasing part, dy dx less than 0. Turning point, dy dx equals to 0. For an increasing function, the slope is always positive. Can you see? That's why dy dx is greater than 0. Okay, second type of question. Two types of question. One of them is to find the range of values of x. The other is to prove something is increasing or the function is decreasing. Okay. So I need to show this. So what do I need to do first? dy dx. So dy dx equals to, what rule do I use? Quotient rule. So I differentiate the top first, put down the bottom. Minus, differentiate the bottom, put down the top. Divided by the bottom square. So I get this function here. Okay, all look here. How do I prove that this is positive? Very good. You see, you all learned this in chapter 1. Then you all were suffering like mad. Now you should have some idea. How do I prove this is positive? 2 is greater than 0. A perfect square is always, look here, greater than 0 when x is not equals to -1, because the question says so. Do you know why the question says this? What happens when x is -1? No, when x is -1, it becomes 0, right? What happened to this function? It becomes undefined. The region there, when x is -1, the graph there is undefined. It's infinity. It's actually go up to infinity. So that's why the question need to state that x cannot be -1. That part will be going towards infinity. All right, so if you have -1, this part will become equal to 0. So I don't want that. I want to write this down, please. Write this down. So that is strictly positive. Strictly positive. So this is strictly positive. This is strictly positive. So dy dx is strictly positive. Therefore, you know these 3 dots means therefore. And y is an increasing function. And that's the end of the lesson. Okay, Jacob.